Alright, so what you can do today is kind of possibly listen through the class. So even if you're not understanding much, that's fine, because we are doing the couple of last questions from departure today. So we have to take departure for you again anyway, so that's fine, but you can just see and understand how that is. If we have time, we will jump into convergency as well, if we have time. Alright, yes, Apeksha, hi. Good morning.
Good morning, sir. Good morning.
How about the homeworks? Perfect. Now let's look at question number 23, and we'll be doing question number 23 and 24 straight away. Right? So yes, Anandu, if you have that paper with you, you can go to question number 23 and 24. See if you can understand. It's not very difficult. You definitely will be, but see if you can. All right. So we will do question number 23 together, and you can do question number 24 after that. I'll give you some time, and then you can go through question number 24. It's almost the same type of question. This was one of the questions which was asked in the attempts, 2 attempts back. So this is actually a good question. So let's look at the question again. An aircraft takes off from 48 north 001 west. So in these kind of departure questions, it's a good idea if you can actually go through the question, understand the question before you start drawing or thinking about it, right? So look at the question. What is our departure coordinates? We are taking off from 48 north, 1 degree west. Correct? We're taking off from 48 degrees north and 1 degrees west. And what is the initial track we are going to fly?
270 westerly.
You are traveling a track of 270, which is a westerly track. Correct? So we are flying a track of 270 degrees, which is a westerly track. So not only it's a westerly track, it's along a parallel of latitude. So which parallel of latitude are we on? We are going to follow the same parallel of latitude towards the west. So it is 48 degrees north. Perfect.
No.
Yeah. All right. Now, how long is that happening? How long are we tracking 270?
2 hours 15.
That's 2 hours 15 minutes. So you can write this as 0 to 15 hours, but it's 2 hours and 15 minutes. And then what happens? It alters its track to 360 after that. So basically you can see I'm somewhere here, I'm traveling to the west first, and then I'm traveling north. So when you draw, make sure you have space for a westerly travel and for a northerly travel. Right? So let's see that again. Let's draw these. So everything is happening in the northern hemisphere here. So let's draw that. Right, this is east, north, west, south, and we are on 48 degrees north parallel of latitude, right? And what meridian are we on? We are on 1 degree west meridian.
1 degree west.
Right, so I hope you understood when I draw this 1 degree west towards that side that I'm looking for more space to play around over here, right? So this is 1 degree west meridian. Yes, Anandu, I'm just trying to fix the coordinates of the departure station here. So this is the point we are starting from. So let me mark this point as point A, and the coordinates of this point is 48 north and 1 west. So this meridian is 1 degrees west. Now we are traveling on a westerly track. From here we are traveling westerly. Yes, Apeksha, what are the parameters? Westerly track, which means I'm traveling along the same parallel of latitude, right? For how long?
2 hours 15 minutes.
For 2 hours and 15 minutes, yes. And then what is happening after that? After reaching some random meridian, I'm then tracking 360.
60.
And what track is that? Yeah.
Towards north.
So 360 degree is a northerly track. So northerly track means along what are we tracking?
Along a meridian.
Very good, along a meridian. So you have to first draw the meridian there. See, now you're getting an idea, right? How things are actually going. When you do multiple questions, you will get that. Now this is, but we don't know which meridian this is. If I want to find this meridian, I have to find the Chilong. If I want to find the Chilong, then I have the latitude here, and I also need the departure. And if I want to find the departure, I have the time here, I also need the speed. So you can see how it's all connected, right? Then once you reach here, you're tracking north, how long is that happening? It's not given. Deltas, it's tracked to 360, and then it after tracking 360, it then tracks 0, nano 0, right? So it tracks to 360. So let me mark this particular point as B. And then it tracks towards 360, and we don't know how long it is tracking. Therefore, after tracking, flying a track of 360 northerly track, it will reach some other parallel of latitude. Remember, there is no change in longitude here, only the latitude is going to change in this particular leg. Over here, there is no change in latitude, only the longitude is changing over the first leg. So over here, the aircraft would reach some random parallel of latitude here. That let me mark this point as C. And what is happening after that? It is now tracking easterly, 0, nano 0, right? So from here it is now turning right. The aircraft turns right over a track of 090. And how far is that happening? It tracks 090
1
after flying on an easterly track for 1 hour 40. So after traveling on this easterly track of 1 hour and 40 minutes, what's told in the question? The aircraft crosses the meridian of 1 degree west again. So you see here, the 1 degree west meridian is here. So from here, after tracking for how long? 1 hour and 40 minutes. What happens to the aircraft? The aircraft crosses this initial meridian again, which means the aircraft finally ends up reaching there, right? So this point C, and I'll mark this as point D. Is that clear? So we fly a westerly track first, and then we turn right over to northerly track, again right to an easterly track. And during that easterly tracking, you track for 01 hours and 40 minutes. And then you end up intersecting the initial meridian of 1 degrees west, right? These are small clues which is actually put in the question. All right. Now, while flying on the, if the ground speed of the aircraft was constant, and that makes it a bit more easier. Now, they haven't told you the individual ground speeds, rather they are saying that the ground speed of the aircraft was constant throughout the leg, which means it is constant everywhere. What's the value of the ground speed? It is 440 is the value of ground speed, right? So ground speed here is 440 knots, ground speed here is 440 knots, and the ground speed here is also 440 knots. So all these legs, now it is pretty easy, right? Now it's exactly what we just told before. Now what is the question here? Find if the ground speed of the aircraft was constant at 440 knots, what was the flight time on the second leg? Now which is the first leg here? The first leg is the westerly leg, AB. The second leg is the northerly leg along the meridian, BC. And third leg is CD, again an easterly track along the parallel of altitude, leg 3. We know that the time taken from AB is 2 hours 15 minutes, from CD is 1 hour 40 minutes. We don't know this time. This is the second leg. You're asked to find out the time taken by the aircraft along the second leg. Typical departure question which is asked in the exam, right? Now I'll give you some time, Apeksha. Now you have the figure with you. It is not always necessary that you have to draw a beautiful figure like this for the exam for every single question. You might not get so much time because there are other questions which need more than a minute to find the answer. So it is only in these questions that you can save some time. So, but initially when you learn, I always recommend you draw all these diagrams properly. That it becomes much easier for you in the exam, right? Now I'll give you some time. We can take 2 minutes, and you can kind of see how you can do or go about this question.
The departure is 919 nautical miles.
Yeah. So what you're trying to find out, you found out departure on the first leg using the time and the speed. Remember, did you really take care of the time here? 0215 hours. It's a 2.15 hours?
It's 2.25.
That's right, 2.25. It's 1/4 of an hour, 2 point, very good. Yes, so using that you found the departure. Now what are you doing next? What are we trying to do next? You found the departure first and then? Geelong, very good, yes. So first we have leg 1. Okay, now look at the board. Let me quickly tell you. What are we asked to find out here? We are asked to find out the time along the second leg, right? So what's the basic equation? Yes, Apeksha, look at the board. What's the basic equation? Speed is equal to distance divided by time. Which means if I want to find the time, I need distance and I also need the ground speed, right? Yeah, I have the ground speed with me, second leg. So what are we ultimately trying to find out? You're trying to find out the distance. And once you get the distance, you divide it, you get the time. So how will you find this distance? This is along a great circle, yeah. So great circle, if I want to find out distance in nautical miles, I simply have to find out the chilat in minutes, and I can directly convert that to nautical miles, right? So whatever the distance here it is, it's going to be exactly the same number of minutes of change of latitude. So I want to find out chilat here. If I can find the chilat here, I can find the distance, correct? Now, how to find chilat? I have the initial latitude, I need the final latitude. So ultimately, what are we trying to find out? We are trying to find out this unknown latitude here. Now, how will I find the unknown latitude there? By using departure equation, because departure equation is one equation which has latitude component in it. So departure equation is what? Chilong into cos of latitude, and the cos of latitude is the one which we need to find out. We find the cos inverse of that, right? But we also need the Chilong, and that Chilong is what you're trying to find out now, because it's going to be the same. It's the same meridian. Understood? So what are we trying to find out? Perfect. Yes. So leg 1, let's find out what the departure is. So departure in nautical miles is equal to, so distance is speed into time. Speed is 440 knots. I always have the habit of carrying forward the units because that will make you understand the units to match. Into 2 hours 15 minutes, you can put in your scientific calculator and you can kind of convert it. It is 2.25 hours. How much is this?
990 nautical.
That's right, 990 nautical miles, right? Now what is the basic departure equation? Let's write that. Yes, Anandu, do you remember what the departure equation is? No. So departure in nautical miles is equal to change in longitude. Yes, Apeksha, you can help him.
Change in longitude in minutes into cos of
latitude. Remember, if you are not along any parallel of latitude, if you are along a great circle, then departure the nautical mile distance is exactly equal to change in longitude in minutes. But if you are along a parallel of latitude, the cos of that particular lat will also be a function reducing the departure.